Yeah, so firstly, mm, uh, thank you so much for giving me this opportunity, and I would like to start the presentation. Um, this is my final project presentation on predicting the power output of a combined cycle power plant using machine learning. So let's dive in. So a combined cycle power plant or CCPP use both gas and steam turbines to generate the electricity. The hot exhaust from the gas turbines is used to power a steam turbine for improving the efficiency. These systems are widely used for base load power generation because of their high efficiency. So let's move to the problem type and evaluation metrics. In this project, I'm solving a regression problem. The goal is to predict the net hourly electrical energy output labeled as PE using four ambient features. One is the temperature, and the second is the ambient pressure and relative humidity and exhaust vacuum. Since this is a regression task, I choose root mean square error or RMSE as evaluation metric because it penalizes large errors and is commonly used in the energy forecasting. So let's move with understanding of the data. So we have a data set of like 9,568 records, each representing hourly averages of the mentioned features. Temperature had the strongest negative correlation with power output, meaning higher temperatures. Often it reduces the plant's efficiency. So this insight helps in like feature prioritization and model tuning. And if we look at the training and the test strategy, like I split the data set into 80% training and 20% test data. I used a five-fold cross-validation on the training set to ensure the model generalized well. I compared two models, linear regression for its simplicity and interpretability, and random forest for its robustness and ability to model non-linear relationships. And if we go to the model performance on this particular validation set, so the linear regression model had an RMSE of about 4.54, whereas the random forest model achieved an RMSE of 3.67 on the validation. Based on this better performance and the fact that it captured features interactions more effectively, I selected random forest as the final model. And finally, evaluation on the test set. So on the test set, like the random forest model achieved an RMSE of 3.72. This means we can say like model predictions are on average within about 3.7 megawatts of the actual output. It's kind of like a good result, I can say, giving the range of PE values in the data sets. Let's see the what are the insights and the interpretation in the current slide. Temperatures turned out to be the most influential feature, followed by ambient pressure. The model performed consistently across different environmental conditions, making it as a reliable tool for short-term energy forecasting or the power grid consumption. And if you see the conclusion, so to summarize, I can say like I correctly identified the problem as regression, selected RMSE as the metric, compared two models using cross-validation, and selected one with the lowest error. Like this project demonstrates how we can apply machine learning, especially to the real-world systems for you improving the planning and the performance. Yeah, that's all from my side. Thank you so much for listening.